Hi there, Grant Gilbert from the EDO lab coming to you today, and I want to clarify a few things about clarity, specifically distortion and chromatic aberrations, and what they are, and some cool solutions that have just released. They're hot on the market. They just released last week at Vision Expo. So the first one I want to talk about is distortion. When we talk about distortion, the main thing we do to reduce distortion is the base curve selection along with the lens design. The base curve that we pick is heavily influenced off the prescription, and the base curve, it really optimizes the optics that we choose to pair and marry with that. And the magic of the Camber lens design is that it has a variable base curve lens. And so you've all seen distortion maps before, and the distortion map of Camber specifically is super minimal. And it's because it's got a flatter base curve in the distance, and then it gets steeper and steeper through the progression until you get a very steep lens and the steep base curve in the near area. The benefit of that is this distortion map. This is my crudely drawn distortion map, but if you look at a Camber distortion map, it's maximal. The quarter width is, you could drive a truck through it, right? And so when we talk about distortion in a lens, it's really the pairing of base curve to lens design and the lens design itself, about where it moves the lens and where the design is within the lens, within the lens itself. The other variable when it comes to clarity is chromatic aberration. And if you've seen the Pink Floyd cover album, this is my crudely drawn Pink Floyd cover album. And it's basically, the concept is that as light enters a prism, it expands into all the different wavelengths of light and comes out the other side as it goes through. The same thing happens in your lenses, which is as light goes in, especially in the periphery, the light can get dispersed, and that's where you get rainbow effects around the edge. This is especially guilty in materials such as polycarbonate and high index 167. People often use 167 because they think, I want the best, most thinnest lenses. But the problem is you don't realize that you're actually sacrificing chromatic aberration. And so a patient in a high index lens might get rainbow effects. So there's the two problems, both distortion and chromatic aberration. And the Camber Pure lens design, which just released last week, it just released right now here from EDO, solves both of these problems. It solves the distortion problem with an aspheric front curve, and it solves the chromatic aberration problem, which is unlike anything on the market. No other lens design can do this, because what they developed is a proprietary technology to correct for this happening on the periphery of a lens and bring those colors back in. It really does produce the best quality lens you can imagine, and it reduces those problems that low ABBE value materials have. So if you're interested in learning more, look out for some webinars coming from us. We're going to be doing some dinners for lunch and learn type events. Ask Ray or Christina, ask your customer service rep, and look for some materials from us, because we're really excited about this product and excited to just continue elevating the game, to be corny about it, and bring in new technologies such as the Camber Pure. Thanks.